Sean Carroll is the Alan Wilson Professor of Molecular Biology and Genetics here at the University of Wisconsin, and he is also the Vice President for Science Education at the Howard Hughes Medical Institute. And with that, welcome Sean Carroll.
This morning I'm going to talk about the denial of evolution and about the evolution of denial. And I hope to show you how indeed we have all been here before. For inspiration, I'm going to call upon a writer, although certainly not a science writer. Why not Albert Camus? But I thought, pick somebody who knew what Hitler meant as he lived through the occupation of France and knew what a communist was. These are terms thrown around, of course, in the public sphere these days, kind of lost their gravity. But Camus in 1946, just as Europe was awakening from the nightmare of World War II, was confronting the outbreak of the Cold War. And he said at the time that we're living in nihilism. We shall not get out of it by pretending to ignore the evil of our time or by deciding to deny it. The only hope is to name it on the contrary and to inventory it to discover the cure for the disease. So I'm just going to take a little liberty with Albert's words and say, we are living in denialism. And what we need to do is inventory it, understand it, before we can come up with some possible remedies for this disease. So I'm going to talk about the denial of evolution. And as a working evolutionary biologist, of course, this was my introduction to denialism. Confronted it pretty much my whole career. And I'll start here with sort of a confession, which is, I think, certainly for myself, and I think for the vast majority of my colleagues, when encountering this, we first thought it was about data. Because some of the arguments were about data. Some of the arguments were, oh, that doesn't prove that, or you don't know that, et cetera. Oh, no, we'll show you we know that. Now that we'll find out even more stuff. So actually, we are in a golden age, not just of science, but in evolutionary science. The last 20 years or so have been fabulous in terms of our understanding the history of life and the mechanisms of evolution. That's great. Yet nothing's really changed in the public sphere, and all surveys that have been taken in the American public for the last 30, 40 years show the same thing. And that's because it's never been about the data. Okay? Took a while. Okay? We've had the data a while, but I do want to acknowledge, this sentiment is out there. The astonishing revelations of recent research in paleontology have done still more to turn what 20 years ago was a brilliant speculation to an established and unquestionable truth. This from the Times of London in April 21, 1882. That was Darwin's obituary. So 130 years later, we're still here. So it's not about the data. Rather, most certainly, I think that this is a very honest reflection of at least what it's about in terms of evolution in this country. When science and the Bible differ, science has obviously misinterpreted its data. And this is from Henry Morris, the co-founder of the Institute for Creation Research, which was a major force in advocating creation science as a discipline and creation science into textbooks and an early round of legal cases, and is really sort of a predecessor to intelligent design. So this is the issue. It's not about the data. So if it's not about the data, what are we talking about, and how might we deal with it? And so what I want to share with you is my personal epiphany. I hope you'll find it at least enlightening for a few minutes. And it came from an obscure and entirely unexpected place for me. I was researching something for entirely different reasons, and I encountered this article. It's from the PEDIATRICS journal in the year 2000. The age doesn't matter. The analysis is timeless. And this is the analysis of a microbiologist and 2 chiropractors of the historical opposition to vaccination among the chiropractors. And using Arthur's guide here, I'll just tell you the giveaway here is that when I read this paper, I had a terrible case of déjà vu, which also means I learned something because it resonated with me in a particular way. So I want to take a few minutes to explain to you why understanding chiropractors' approaches to or attitudes about vaccination was so enlightening to me. So in this article, the 3 authors were prompted by their concerns, particularly the 2 chiropractic authors, were concerned about what they saw as their colleagues' attitudes in the profession about vaccination. And those attitudes, for example, were reflected in various small-scale surveys, such as in a 1992 survey that showed 37% of the American chiropractors surveyed then thought that there was no scientific proof that immunization prevents infectious disease. Or another survey of Boston chiropractors that only 30% of them recommended childhood vaccination, and that 42% of chiropractors responding to a 1999 survey reported that their own children had received no vaccinations. And so these chiropractors were concerned because they thought this was doing damage to their profession. So the article is about a historical analysis, sort of the roots of chiropractic, and how those attitudes still persisted, at the turn of this most recent century. And they explained the history of chiropractic, founded by D.D. Palmer in 1895. He defined chiropractic as an art, a science, and a philosophy. He asserted that correcting vertebral subluxations, so sort of misalignments of the spine, influenced the life force within the body. So that was the working principle of chiropractic. And established a school in Davenport, Iowa. And this school was left to his son, Bartlett Joshua Palmer, who became active and a leader in the field subsequent to his father. And it was Bartlett Joshua had various comments with respect to the relationship between spinal misalignments and disease. He specifically rejected the germ theory of disease. He understood that germs existed, but he thought that germs could only thrive because of underlying problems with the spine. And so he said things like, for example, vaccine virus or other poisons will not permanently affect the patient when the chiropractor keeps the vertebra in proper position. Now, you might think this is sort of quaint turn of the last century, thinking. But what really shocked me was when I dug now more into this general topic and learned about the attitudes of chiropractors in the 1950s towards polio and the advent of the polio vaccine. So polio victims were a common patient population for chiropractors. Obviously, there were lots of physical problems that polio patients were dealing with. Chiropractors offered their methodologies for potential therapy. So it was actively promoted. This is a brochure from the Los Angeles Chiropractic Association from April 1954. Not only did they advocate very prompt therapy for polio victims within the first few days of being struck, the operating theory was that spinal adjustment did something to disperse the so-called fatigue toxins. And they claimed unusual success, although I now have to sort of insert a little bit that really with just minimal supportive care, the recovery rate from polio was about 60%. And that's essentially what the chiropractors observed. So I'm going to get a little jab in here, but there's not a sense of controlled clinical trials. Okay. What shocked me even more, this is April 1954, the vaccine was introduced in 1955. Is that they actively opposed and disputed the efficacy of polio vaccine. So they actively opposed the public campaigns, the March of Dimes, federal and state agencies to get everyone vaccinated to control this disease. Let me share with you just one particular quote from the Denver Post, from the member of the Colorado Chiropractic Association. You can read it out. But think now about sort of the techniques being used, the language being used to persuade readers. Your thoughtful consideration should be given to the fact that contamination of the human body through the injection of diseased animal cells must be abhorrent to the Creator, who equipped us with cell life peculiar our own and is not mixable with that of animals. Okay, so an argument against injecting foreign substances was just one of many to suggest that the vaccine shouldn't be used. Now you might think, as you know about the story of polio, that data would change this. So I want to at least show you a little data. This is the epidemiological reporting of polio cases, and we have much more data since then, but I think you can tell the trend over the years before the vaccine was introduced and then subsequently. So the vaccine was introduced in 1955. It took a while, of course, for everyone to be vaccinated and for the full course of immunizations to take place, but you can start to see relative to about 28,000 cases in 55 or 38,000 in 54, you start seeing a tapering, and then obviously things are dropping by orders of magnitude. Okay. So, a science success story. Certainly I know growing up in the 60s, this is something I always heard, Jonas Salk was a American hero for doing this, but not in all communities. As late as 1959, the National Organization of the Chiropractic, the Journal of the National Chiropractic Association, was making such comments published in their journal in 1959 that the test tube fight against polio has failed, alleging the death rate has increased among the children who've been vaccinated. There's no vaccine against fatigue or a traumatic lesion in the anterior cord. Whereas in the mild and especially the more acute cases, chiropractic is supreme. Adjustments to the entire spine will break up the cord congestion. So 4 years after the introduction of the polio vaccine, arguments were still being made that that was a failure, that that was dangerous, and that chiropractic was the method that should be used. So I found this really, really surprising. But again, this was an episode 50 years ago. What the chiropractics I was reading in the 2000 article in Pediatrics were talking about was attitudes, in the last decade or so. And why I found this article so informative is they really spelled out the major arguments that chiropractic had been making now for almost a century against vaccination. And when I read those arguments, I had that deja vu feeling because I could superimpose those arguments entirely upon what I had been reading from the anti-evolution forces. So I saw in this paper a general manual of denialism. And with a little bit of sort of recoding of some of the statements, I really understood that to deny a piece of science, there was sort of a common playbook, a common set of tactics. So what I want to do is I want to give you those 6 arguments in outline, the 6 broad sort of categories of arguments in outline, and let you sort of rest on those for a minute and see how well you think those fit to the cases of denialism that you've ever thought about or studied or heard about, whatever. See if you think it's a fairly good fit. Give you enough time to jot them down as a note if you think they are worthwhile. But to me, the benefit of organizing these was to realize that you can throw any argument at me now about evolution, climate change, et cetera, and it's in one of these 6 bins. Okay? So here are the bins. Start by doubting the science. Anything that can be done to shed doubt on the science. All right, in evolution's case, that would be that, arguments about mutation or arguments about fossils or arguments that radio dating is invalid. Take what you like. The second is to question scientists' motives and integrity. Okay, so if it's not necessarily the data that's mistaken, it's the motivation of the people behind the data, that they have some agenda, or that they're motivated by profit, for example, in the case of, let's say, vaccines. The other is to magnify normal, legitimate disagreements among scientists, it's the way science works, and to cite gadflies as authorities. And what I mean by gadflies, of course, is a small number of people, perhaps largely maybe credentialed doctors, credentialed scientists, who hold a minority opinion, a tiny minority opinion, against whatever the consensus might be. And then we often see that in certain settings as balance, in that you hear these 2 voices, even though those 2 voices do not represent equally sized constituencies in the scientific community. Exaggerate potential harm. And I would sort of say this is sort of a sliding bar here, because if these things aren't working, scare the hell out of people, okay? Or it could be sort of mixed in with the others. But to exaggerate potential harm means to say that even if this is factually correct, you got to realize that there's danger here. I think another parachute is just appeal to personal freedom. All right, but I'm an American, I don't have to. And that's a very important strain of feeling in our country. And I think what it fundamentally boils down to in so many cases is that to accept the science would repudiate some key philosophy, whatever that might be. Okay? So from a scholarly level, this is my contribution today. All right? These 6, dug out of my twisted path through evolutionary biology and reading about chiropractors. I just want to give you enough time to absorb this. This might be framing, who knows, for some subsequent questions. Now, to back this up, I'm just going to show you a few quotes related to some of these points so you get the feel of these arguments, although many of you in the room would probably be familiar with this. And I don't want to bash you to death with too much quoting, but nonetheless, I think it's worthwhile seeing how these arguments look like and sound like. So how do we doubt the science? Well, with respect to chiropractors and vaccination, the argument is that, well, the Centers for Disease Control Statistics, they make it clear that the majority of diseases that are now routinely vaccinated against were disappearing before either the cause was discovered or the vaccine developed. So these things would have disappeared anyway. Same argument applied to polio. The equivalent in evolution is there's no real scientific evidence that evolution's occurring at present or ever occurred in the past. Evolution's not a fact of science. In fact, it's not even science at all. Okay? I'm just going to jump ahead. How about exaggerating harm? You can find plenty of this in medical arguments against vaccination. Biology and healthcare students need to learn the demonstrated adverse events associated with childhood vaccines: death, encephalopathy, demyelinating diseases, infections, anaphylaxis, arthritis, etc. And certainly that's true if those are really some of the clinical experience directly attributable to vaccines, then people should know about adverse events, and adverse events do happen with vaccines. However, there's no emphasis on the adverse event of not vaccinating and what happens to community immunity and epidemics, risk to particular patient populations, etc. Now, in the case of evolution, what harm is there, in fossils? Certainly the harm in Darwin, and this is not an uncommon argument, that the many factors that produced the Nazi Holocaust and World War II, one of the most important was Darwin's notion that evolutionary progress occurs mainly as a result of the elimination of the weak and the struggle for survival. So, if Darwin was, couldn't possibly be true because these things are evil, rather than, of course, Darwin was being misappropriated, if indeed he was misappropriated to horror. Appeal to personal freedom, that nothing should be compulsory. So let me show you right off the current website of the American Chiropractic Association, the policy they adopted in the 90s and hold to this day. So, resolved, since the scientific community acknowledges that the use of vaccines is not without risk, etc., the Chiropractic Association supports each individual's right to freedom of choice in his or her own health care based on informed awareness of the benefits and possible adverse effects of vaccination, supportive of a conscious clause or waiver in compulsory vaccination laws, maintaining an individual's right to freedom of choice in healthcare matters. Now, a little context to that, there's a century-long tension between the conventional medical community and chiropractic about lots and lots of diseases and how they're treated. And so this sort of individual right of freedom to choose how one gets their health care is just deeply embedded. In the case of evolutionary biology, there's ideas like teach alternatives, teach balance, teach the controversy, or just allow students to opt out of studying evolution altogether as a matter of personal freedom. If they find an objection to this line of thought, just opt out. And in terms of reputing the key philosophy, here's the issue. Now, there's, of course, layers of these issues, but certainly if the fundamental premise of your discipline is that disease is a result of misalignments of the spine, then acceptance of the germ theory and vaccination would repudiate the founding premise of the discipline. And this, for a significant percentage of the chiropractic community today, is the issue. Okay? So it's just ground they can't give. Similar ground on religious grounds in the case of those that adhere to a fundamental perspective on the Bible. The issue about evolution is that if the earth is as old as scientists say, if things have changed naturally, if humans came here naturally, if we evolved from preceding forms, that this undermines their reading of Scripture, and hence the validity of the gospel message. So that's a really, really huge obstacle. And I'm not trying to say it, I'm just trying to characterize this the way it is. This is the obstacle if you're an evolutionary scientist or educator for perhaps 35% of the country in terms of accepting evolutionary science. All right, so there's where we are. Where do we go from here? And I'm sure over the 2 days we're going to be talking about the power of these sorts of arguments and the entrenchment that leads to and how difficult it is to get people to change their minds. And I really wrestled with this. I think it's a difficult reality to face, I think, as an evolutionary biologist who really thinks that we've made tremendous amounts of progress in 150 years, in the last 25 years, to realize that perhaps half the country is deaf to anything you could possibly say. especially if you think the story you have to tell is really a magnificent achievement of humans figuring out where we came from and of understanding the complex relationships of living things on the planet and the deep, deep history of our own species. Magnificent stuff. Not interested. So where do we go? Are there any cures? There's no way I'm going to sit here and tell you that I've discovered any particular cure, but doing nothing is not acceptable. So what are we going to do? And I subscribe here to H.G. Wells' maxim that human history becomes more and more a race between education and catastrophe. So I choose education until catastrophe takes us all away. So I'm going to change the perspective here a little bit from, and I think it may be an interesting part of our discussion, to what you as science writers in any medium are facing and maybe what the educational landscape is like, or what the opportunity the educational landscape presents. So I'll just tell you flat out, after talking, writing, et cetera, about evolution for a lot of years to the general public, I certainly know that 99.9% of anyone I ever interacted with was already a member of the choir. The only people that I had an interesting experience with a glimmer of changing minds were, I would say, people under 22. So I don't know how much, I should know better, I don't know how much social science research holds this up, but I think it's really hard to change people's minds somewhere around that college age to college graduate age. And so to me as a scientist, you just have to decide, then you got to go younger. This is the only way we're going to approach this. And you may have to change your methodology, that packing the textbooks with really deeper and deeper knowledge is not necessarily the way to get people to understand what you're talking about. So I'm going to talk about what I think we all have in common, whether we're scientists, scientist educators, journalists, et cetera, which is storytelling. And I'm going to talk about the power of storytelling. And if anything, while I don't think anyone here in the media is going to be enlightened by what I have to say, it's just a reminder, a conscious reminder to educators and to fellow scientists that everything we do is about storytelling. When we talk to our students, when we talk to each other, it is all about storytelling. And being more effective storytellers, both in terms of content and method, is one thing that we can certainly work on. And I'm going to offer you, for your critical input, an example of that. Okay, so I think Rudyard Kipling put this best. I just subscribe to his theory, his educational theory, that if history were taught in the form of stories, it would never be forgotten. Okay? If my kids can remember movie lines, and I can remember what happened in a Red Sox game in 1967, and 75, and 86, okay, and this weekend, there's something to storytelling. There's something about that whole impact of a narrative running through our heads. So why should we tell stories? Well, it turns out there's a big area of psychological research in this, and it's an area called narrative theory, and a branch of cognitive psychology. And research in this area talks about how human thought is fundamentally structured around stories. Right? I mean, what were people talking about in the break? What were you doing last? Well, for example, Deb started out with the story of, we stayed really late last night. And there probably could have been some stories that she prudently then deleted. But whenever we're interacting with each other, right? Did you see this last night? Or, I was driving in this morning and I saw, a deer across the road and da-da-da-da-da. Well, where does this lead us, the telling of stories? Well, we use narratives to understand cause and effect and the connection between events over time. Right? This is one aspect above our neurons are involved in this, but this is how we're holding on to things, is understanding connections between events and cause and effect. And we learn from stories because a well-told story or well-understood story presents a coherent argument in favor of a conclusion. At a deeper level, I think at sort of the next level of storytelling, there's this possibility of immersion and transport, what Spielberg and James Cameron and Ridley Scott go after. Immersion in the story transports that reader, that viewer, that listener into the world of the story, who then shares the motivations and emotions with the protagonist. And that immersion experience shapes and can change beliefs and attitudes. So how do we make storytelling more immersive? How do we transport our listeners, our readers, our viewers, or whatever, to another place where they'll stay or where they might absorb something more? Well, Jerome Bruner, who's one of the founders of this field, in his book, The Culture of Education, talks specifically about storytelling as it concerns science. That science, in fact, lends itself to narrative storytelling because the process of science is narrative. It consists of spinning hypotheses about nature and testing them and correcting the hypotheses and getting one's head straight, as he says. The history of science can be dramatically recounted as a set of almost heroic narratives in problem solving. So these thoughts really resonated with me, and certainly after 20 some odd years of experience of teaching here at the University of Wisconsin, I had noticed that when, occasionally, I went off topic and might get lost for 15 or 20 minutes in some story about some characters in science and some adventures they were on or some peculiar intersection with our culture, that the students would even see me years later on Henry Mall or on the downtown square and say, I still remember some of those stories you told. And I know they didn't remember any of the genetics I taught them. So, humbling experience, except for it just reinforced the notion that the stories count. So I started telling a lot more stories, and that's really what led me down the path to writing more. But then I learned there's only the dissemination of written stories. There's some limits of the medium. And when you're looking for immersion, I think there's other media besides the printed word that can carry a lot more weight. And that's one of the major reasons I went to HHMI to get involved in science education, and why we founded a film unit, a television and film unit called Tanglebank Studios, with a goal of producing long-form broadcast and theatrical films about science and scientists. But equally important, and maybe we'll find out, we'll know the data some decade from now, maybe as or more importantly, to craft short educational films for the classroom. So here it is. Here's the strategy. My kids, 2 college-age kids, don't own TVs. They don't pay cable bills. A lot of parents, you can look at nodding here. Those of you who have parents of kids maybe that have left home, do they own a TV? Are they watching? Are they paying that cable bill? It's really going out of style. So if you gave me the job, Sean, produce programs for those 25-year-olds, I don't know how to reach them. 18 and under, I know how to reach them. Where they're captive in the classroom, where they have an authority figure at the front of the classroom, where they have an authority figure that has 50 minutes with them to elaborate anything that might be there in, say, for example, a short film or any sort of short story that we might share with them. Furthermore, and keep this in mind, 4 million of those kids become voters every year, while 4 million other voters die. So in a decade, that's 40 million new members of the electorate, and 40 million gone, okay? So it's a long-term campaign. Can we do a better job of getting across science in the classroom? And the dots I'm trying to connect is that can scientists like myself, all of us, can organizations like nonprofits like Hughes work with teachers in their vast numbers and equip them better and make a dent? Well, maybe. So we're launching on this experiment of making these short films, and I'm going to share one with you. And shock of all shocks, it's in the area of evolution. So these are short stories. Teachers tell us that 10 or 12 minutes is about the right length in a classroom. They've got 50 minutes. It leaves the other 40 for the teachers. And especially if you support these films with activities that are really relevant, and if these films are right on the button in terms of curricular requirements, they're enthusiastic about it. But as an evolutionary biologist, we want to tell stories of how evolution works. And the advantage of this last 20 years golden age of evolutionary science is that lots and lots of examples of the evolutionary process have been clarified, buttoned up, where we understand every element to the story. the role of natural selection right down to the exact base parent DNA that's changed, that's enabled an organism to adapt to, for example, some new habitat. And that empowers us to really address some common just misunderstanding, misconceptions, and deliberate misinformation that's out there. So in the case of evolution, that's about things like the idea that evolution is random. There's an important component of that, but that's not the entire process. That it's slow, so slow these things couldn't have happened. That it's rare, unlikely, that mutations are only destructive and cannot generate new capabilities, or for example, that humans are not evolving. So there's ways to address this from great empirical stories. And the other ingredients to these stories are that not only do you need a button-up example, but you need some engaging way to tell this visually. So we've worked with superb filmmakers. I really want you just to sit back and relax and enjoy this film. You're now in the classroom. You will be the judge of whether or not this works. Across the American Southwest, golden deserts dotted by cacti and brush stretch for miles. Yet here in New Mexico's Valley of Fire, the landscape changes dramatically. Patches of black rock interrupt the sand, remnants of volcanic eruptions that occurred about 1,000 years ago. The eruption spewed a river of lava more than 40 miles long across the desert. As the molten rock cooled, it darkened, leaving any creature dependent upon camouflage in serious trouble. In the complex battle of life, one of the constant struggles is between seeing and not being seen, the evolutionary game of hide and seek. And we've come here to the Valley of Fire in New Mexico, a battlefield, to find one of the tiniest soldiers and what it can teach us about how evolution works. On the desert sands, the rock pocket mouse blends in perfectly, its light-colored fur concealing it from predators. But on dark lava, the same fur makes the mouse stand out, attracting the many creatures that see it as food.
These mice are the Snickers bar of the desert. They're eaten by foxes and coyotes and rattlesnakes, and certainly by owls, and maybe even occasionally hawks. And most of those predators are visual predators.
So what happened to the pocket mice that found themselves on this new terrain? When I accompany biologist Michael Nachman onto the lava, it doesn't take long to find out.
Oh, this one's closed.
Nachman has been collecting mice unharmed in traps. And it's a dark one.
It is, yeah.
Now, are most of the ones you find up here dark?
Almost all of them.
Not only have the mice here evolved to be as dark as the rock,
Shake them into the bag.
the color change has occurred precisely where it will conceal them from hunters. Now, a bit of a white underbelly, too.
That's right. All of the dark ones here and on other lava flows have a white underbelly, and presumably there's no selection for dark on the belly because predators are coming from above.
Left to themselves, the mice show no preference for light or dark rocks. It's the predators that have made the difference.
The change in color over evolutionary time in the population is driven by predators weeding out the mice that don't match their background.
But how did the dark mice arise in the first place?
When a black mouse appears in a light population of mice, that is usually going to be due to a new mutation. And those are random and rare events.
To fully understand the pocket mouse transformation, Nachman moves from the lava to the lab. He and his team extract DNA from light and dark mice taken from one desert region. The aim? To find one or more genetic mutations that cause dark coloration. A mutation is a change in the chemical letters that make up our genes. It's a copying error
that may occur when our cells divide. Mutation seems to mean that something bad has happened. Well, mutations are neither good or bad. Whether they are favored or whether they are rejected or whether they're just neutral depends upon the conditions an organism finds itself. So for the pocket mouse, a mutation that caused the mouse to turn black, that is good if you're living on black rock. It's bad if you're living out in the sandy desert.
The light mice are all on the bottom, here.
Fur color is a trait controlled by many genes. To figure out how dark mice evolved, Nachman focuses on how these genes differ in dark and light mice. One by one, the genes prove identical, but at last, something does turn up. The difference between dark and light mice boils down to a difference of 4 chemical letters in a gene called MC1R. Because the gene controls the amount of dark pigment in a mouse's hair follicles, a mouse with these mutations grows dark fur, which gives it an advantage on a dark background. But still, that's one mouse. How would its dark fur spread to a whole population?
This lava flow is about 1,000 years old. And so you might wonder, has there been enough time? It's only been 1,000 years. It's a very short period of time for a new mutation to come along and spread, and so that all of the mice on this lava flow are black, because really they all are.
Indeed, such a rapid spread of a mutation may seem unlikely until you do the math. And the reason is that while only one new mouse born in 100,000 may be black, hundreds of thousands of mice are born in any given year. And then those mice that are black have enough advantage that their babies do better, and they have more offspring, and their offspring have more offspring. And just about a 5% advantage, compounded year in and year out, can very quickly turn the whole population black, as we see today. If dark color gives mice a 1% competitive advantage, and you start with 1% of the population being dark, then about 1,000 years, 95% of the mice will be dark. If instead, the dark color gives them a 10% advantage, then it only takes 100 years. Thanks to Nachman's mice, science has an example of evolution crystal clear in every detail.
What's exciting about this is that we have a system that's very simple ecologically. You have dark rocks and you have light rocks, and you have dark mice and light mice. It couldn't be simpler.
We know who the predators are, what the selective force is. We know precisely the genetic basis of what makes the mice have an advantage or a disadvantage depending upon where they live. All the pieces are finally together. It's a perfect illustration of Darwin's process of natural selection. In fact, it's more than that, for Nachman's mice also counter a common misconception that evolution is a random process. Well, there is one random component, and that's the process of mutation. Mutations occur at random throughout our DNA. Every new organism is born with a new set of mutations. But while mutation is random, natural selection is not. Natural selection sorts out the winners and losers, and that's really what the whole process of evolution is driven by. But if natural selection is not random, would it produce the same result under the same conditions? It does. And here's proof. Rock pocket mice collected by Nachman from other lava flows in other parts of the Southwest.
These are 2 different black mice, and they each evolved on different lava flows, and the lava flows are hundreds of miles apart, but the changes, the genetic changes that made these mice black, were different in each case. And what's amazing to me is how similar the black mice are. We didn't know when we started this whether we would find that there were the same genes or different genes, and we were really surprised to find that they were completely different genes, and yet if you look at the mice, they look almost identical.
Clearly, there are different genetic ways to make a mouse dark. But once the beneficial mutations appear, natural selection, the non-random part of evolution, can, under very similar conditions, favor very similar adaptations.
In effect, each of these lava flows is like rewinding the tape of life and allowing evolution to occur again and again. And in each case, we find the dark mice have evolved.
The rock pocket mice show us that evolution can and does repeat itself, and why evolutionary change is never ending. As environments transform, so must the species that inhabit them, adapting and readapting in the great and complex battle of life.
So the idea behind this is to make films of broadcast quality with broadcast experienced producers, and then to craft them word for word in consultation with the primary scientists and with educators, and then to get them to the teachers. And this has been going on, and I have to tell you that the feedback that we have to this point is, gosh darn it, it's really encouraging. Those stories where you combine natural history, so you take students to a new part of the world that they may not have seen, you meet certain creatures, and I think it's really crucial to be a memorable example. As Nachman said, do you remember one phrase? Snickers bars, right? You know, a key phrase can really help. So, you know, this is obviously not a cure, but I do want to remind you that in many ways in the public media, you have a remedial job. Yes, it's keeping current with new science and with new issues that are emerging from new science, but goodness, I'm pointing at science that has been settled science for many, 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 many decades. Yet it's something that really colors our view of the world. So getting into the classroom, at least for some of us, is going to be a really important objective. And what's really different from, say, watching TV or on the internet is there's not a trained adult there guiding them through the material and answering questions or engaging them in a particular activity. So we got to keep our eye on the ball that what happens K through 12 really is going to matter to what kind of electorate and what kind of political discussion we're going to have, 10 or 20 years out. And from these, I just want to close with a little thought again from my buddy Camus. Let's recognize that this is a time for hope, even if it is a difficult hope. Thanks. Thank you.